Okay, today we're going to talk about slope. Slope is a topic you should be very familiar with from Algebra 1, Algebra 2, and from geometry. The slope of a line is a number assigned to that line. That number determines how steep the line is. If the slope is a large number in absolute value, we're not talking about positive or negative, it will be a steep line. If the number is a smaller number, it'll be a flatter line. Let's take a look at the technical definition of slope. Slope is actually a ratio. It's a ratio that compares the change in y to the change in x. Sometimes it's written like this. If you look at the little triangle, that's the letter delta. It's the Greek letter delta, which means change in. So we sometimes notate slope as the change in y over the change in x. When we talk about change mathematically in numbers, it usually means the difference between the two numbers. So if you look at this formula here is a formula you should be fairly familiar with. That is your slope formula, y2 minus y1 over x2 minus x1. What that formula does is it takes the difference of the two y coordinates of 2 points on the line and it divides it by the difference of the two x coordinates of those points. So if we look at our line here, this line will have a positive slope because the line is increasing from left to right. If the line was decreasing from left to right, it would have a negative slope. The difference in the two y's refers to the rise. The rise is right here. It's how it's the difference in the vertical, or it's the vertical change in the line. Then the difference in the two x's represents the horizontal change in the line. So right here represents the horizontal change in the line. So this formula should be very familiar to you. Let's take a look at how to use it. Okay, here we're asked to find the slope between 2 points. Each point has an x coordinate and a y coordinate. So we can call this x, make this a little thicker, x1, which represents the x coordinate of the first point. And we can call this y1. That represents the y coordinate of the first point. Just like that, we can call this x2, representing the x coordinate of the second point, and we can call this y2, representing the y coordinate of the second point. Okay, here is that very familiar formula to you. It is the slope formula. So we're going to go ahead and apply that formula to these points. So if I'm going to calculate the slope of the line between these points, I'm going to take y2 and I'm going to subtract y1. Here's where you need to be careful with your negatives. So y2 minus y1, and I'm going to divide that by x2, so that means the x of the second point, minus the x of the first point. Okay, then we just do the math, making sure that we reduce our fractions in the end. So that is -6, -3 minus -2 is -5 over 4. Since that doesn't reduce, that would be the slope of your line. Now notice that slope is negative. So if we were to graph this line, we would expect the line to decrease from left to right. Okay, let's look at the next one. I'm going to do y2 minus y1, so -3 3 minus 4 divided by x2 minus x1. Now here's where you have to be careful. x2 is 2 minus negative 2. So that would be negative 7 over negative 2 minus 2 is 4. So again, that slope is negative 7/4. Again, a negative slope. When we were to graph that, we would see that the line would decrease from left to right. Okay, so let's do a little review of graphing lines. Two things you always need to know about a line in order to graph it: a point and a slope. You also need a point and a slope to write an equation of a line, which we're going to get to in a little bit. But let's first graph this first line here. I'm going to graph the first line in red. It says graph the line passing through 3, 2 with a slope of 3/4. Okay, there we have a point and a slope. First thing we're going to do is graph the point 3, 2. So you should all know how to graph the point 3, 2. It would be about right there. And now it has a slope of 3/4. Now let's remember what our slope is. Our slope is our rise over our run, which means from this point, the line would rise 3 and run 4. So I'm probably going to go off my graph here, but you'll get the general idea. So from this point, I'm going to rise 3, 1, 2, 3, and then run 1, 2, 3, 4. It'd be somewhere right around there. Okay, then I would just connect the dots to form a line. Well, it's not a very straight line, but we'll go with it. Okay, we put arrows on the end of our line to show that the line goes on forever. Okay, let's look at the next line. Same thing, we're going to pass through the point 3, 2. Okay, but notice now our slope is a negative. Okay, what I usually do is I associate the negative with the rise or the run. I associate the negative with the rise. If the numerator is positive, you rise. If the numerator is negative, you fall. So what I always do is associate the negative with the numerator. So let's see, we're going to graph this one in green. I'm going to start at the same point here, 3, 2. Okay, but now since my numerator is negative, instead of rising 4, I'm going to fall 4. So I'm going to go down 1, 2, 3, 4, and then once again I'm off my graph, over 5. 1, 2, 3, 4, 5. It'd be probably somewhere around there. Okay. Connect the dots with a line. Again, a pretty crooked line. Put arrows on the end, and that would be your line. Okay, and again, it's a negative slope, so as you can see, the line falls from left to right. Okay, now we're going to talk about vertical and horizontal lines. People tend to get these confused, so hopefully I'll give you a couple of ways to remember when you have a vertical line and when you have a horizontal line. Let's first talk about vertical lines. Vertical lines go up and down. Vertical lines are always in the form x equals a number. If you can picture rise and run, a vertical line has no run. Okay, remember the run is on the bottom. It's rise over run. So if a vertical line has no run, that means the run is 0. The denominator of the slope is 0, which we all know you cannot divide by 0, which makes the slope of a vertical line undefined. Okay, because a vertical line has no run, it only rises, the run is 0, which means you have a 0 in the denominator, which means you have an undefined slope. So let's go ahead and graph this one. X equals 2. Whenever we see that x equals a number, we know we have a vertical line. So I'm just going to go to 2 on the x-axis, because we're talking about x, we're not talking about y. So I'm going to put a 2, I'm going to go to 2 on the x-axis, and I'm going to graph a vertical line. Put my arrows, we always put our arrows, and that is the graph of x equals 2. Very simple. X equals -3 is also a vertical line. I see x equals -3, so I simply go to -3 on the x-axis, and I graph a vertical line. Okay. The other way to remember this is that when you see the line x equals 2, that means x is always 2. Y can be whatever it wants, but x has to be 2. So if you look at the line x equals 2, every point on this line has an x coordinate of 2. If we look at the line x equals -3, that means x always has to be -3 and y can be whatever it wants. So if you look at every point on this line, x is -3. Okay, horizontal lines work similarly, except for in a horizontal line, it's in the equation y equals a number. If you picture a horizontal line, let me just draw a horizontal line. This is a fat horizontal line. Notice my horizontal line never rises. It only runs. When there's no, remember, slope is rise over run. So that means that the rise is 0 and the slope, and the run is a number. The rise is 0 and the run is a number. Since 0 is in the numerator, it doesn't matter what the denominator is. Anytime you have 0 in the numerator, the slope will equal 0. So let's go ahead and graph some horizontal lines. Again, we'll graph the first one in red. Y equals 2. I'm simply going to go to 2 on the y-axis, and I know I have a horizontal line, so I draw a horizontal line through that. Okay, notice y equals 2, which means x can be whatever it wants. So if you notice, every point on this line, the x coordinate may be different, but the y coordinate is always 2. So if I wanted to graph the line y equals -3, I'd go to -3 on the y-axis and graph a horizontal line. Okay, now let's take a look at some equations of lines. There are 3 equations of lines we use in algebra. The first one is probably the first one that you ever learned. It's called slope-intercept form. Slope-intercept form is very easy to graph a line when it's in slope-intercept form. The M represents your slope, and the B represents your y-intercept. Your y-intercept is where your line crosses the y-axis. So if I were to graph this first line, let's do it in blue, the first thing we have to do is identify the slope. If I look at this line, the slope is equal to, and we see we have it in the form y equals mx plus b. So this must be my slope. My slope is negative 2/3. And this number right here represents where my line crosses the y-axis. So my line crosses the y-axis at 4. Okay? This is just like what we did earlier. I go to 4 on the y-axis, and again, I have a point and a slope. Okay? The point is my y-intercept. This is the same as the point 0, 4. Okay? So I do have a point and a slope. It just happens to be a special point called the y-intercept. So if I were to graph this one, I would go to 4 on the y-axis. And now my slope is negative. When your slope is negative, you're going to fall and then always run to the right. So I'm going to fall 2 and run to the right 1, 2, 3. Okay? So you either rise and run to the right if you have a positive slope, or you fall and run to the right if you have a negative slope. Again, put my arrows. Okay? And the next line. This slope is a little different. The slope is 3. Now remember, for slope, we need rise over run. 3 is exactly the same as 3 over 1, which means I'm going to rise 3 and run 1. And my y-intercept is negative 2, which is the same as the point 0, negative 2. So I graph my y-intercept first, point first, then slope. Then I'm going to rise 1, 2, 3, run 1, and connect with a line. Okay, so you should all remember that from Algebra 1, and you probably did it in geometry. Okay, let's talk about standard form or general form. Some books call it standard form, some books call it general form. It is basically where you have your x and y's on the left side of your equation, and then you have a constant, remember constant has no variable, on the right side of your equation. Most people, there are many ways to graph this line. Most people like to put it into slope-intercept form. Okay, so let's take a look at this line. 3x so 3x plus 2y equals negative 4. Okay. Basically, when you're putting it into slope-intercept form, you're solving it for y. So you just have to apply some algebra and solve it for y. I'm going to subtract 3x from both sides. But instead of writing negative 4 minus 3x, I'm going to put negative 3x first. Because our line, our slope-intercept form has the x first. Okay? Then I'm going to divide everything by this 2. So what you would end up with is y equals negative 3x, oops, I'm sorry, negative 3 halves x negative 3/2 x minus 2. Okay, and then you just go ahead and graph the line. Our y-intercept is negative 2, and our slope is negative 3/2, so I'm going to go down 1, 2, 3 over 1, 2. Again, notice my line falls from left to right because I have a negative. Whoops, I missed my dot. That's when you make bigger dots. Okay, pause the video and try the next one and see what you end up with. If you paused the video and tried it, you should have ended up with y equals 2/3 x plus 3, and then the graph is the blue line to the right. Okay, the last form of the equation of a line we're going to take a look at is called point-slope form. Point-slope form is actually the most commonly used form, especially when writing equations of a line. It's very basic. You have a point and a slope. M is your slope, just like it is in y equals mx plus b. The only difference here is instead of having your y-intercept, you have a point on that line. And the point on the line is x1, comma, y1. The x1 and the y1 represent a point on your line. It would be this x1 and this y1. Okay? Pay attention to the negatives. This is where people make the most mistakes. But what I want you to do is notice this equation is nothing more than the equation of the slope of a line. Because if you look at this equation right here of the slope of a line, if you were to take this equation and simply multiply both sides by this denominator, or put the m over 1 and cross multiply, you'd end up with the point slope form of a line. So let's take a look at this first one. You have a point and a slope, which are the two things we said we need to write the equation of a line. Here's your x, here's your y. So the point on our line is 1, 3. And the slope of this line is right here. It's 1/2. Okay, so I'll graph this one in red. I go to the point 1, 3, make a point. Always the point first. This time you don't have the y-intercept, so you're not starting on the y-axis. You're starting at the point 1, 3. This means I'm going to rise 1, run 2, and there's the line. Okay. The only thing to be careful with in point slope form is the negatives. Okay. This is my x, so this one passes through the point 2, comma, and here's where you have to be careful. Because in your formula, go up to the top here, there's a minus here, you have to remember to change the sign. Okay? So that when we had a minus 2 here, it became a positive 2 here, and when we had a positive 1 here, it became a negative 1 there. And then our slope is 3, which we can also use 3 over 1 so that we have a rise and a run. So we go to the point 2, negative 1, and then I rise 3, and run 1. This is a good example here of slopes. And notice the first line had a slope of 1/2. Okay, and it's a little bit flatter of a line than this line that had a slope of 3. The line that has a slope of 3 is a bit steeper of line. Writing equations of lines. Remember what I said, that point slope form is probably your best friend when writing equations of lines. So let's make sure that we know what the point slope form of a line is. It is y minus y1 equals m x minus x1. Okay, in certain instances you won't use this equation, and I'll show you when you do not use this equation. Okay, so let's look at the first example. Write an equation of a line containing the point 1, 3, and it has a slope of 2. So I'm going to do y minus, and remember this y represents the y coordinate of your point. So y minus 3 equals, the slope is 2. Okay, we put in the m for slope. And then x, that's a big X, minus this x. So x minus 1. Okay, if you're asked to just write the equation of a line, that's a perfectly fine equation of a line. Sometimes you might be asked to put it into slope-intercept form, or y equals mx plus b. That's an easy task. You just distribute the 2 so that you get y minus 3, equals 2x minus 2. And then you add the 3 to the other side. So you get y equals 2x plus 1. Okay, so you may or may not be asked, ooh, that's really ugly. You may or may not be asked to put it in a slope-intercept form. So if you're just asked to write the equation, this is a perfectly acceptable equation of a line. It happens to be in point slope form. This is the same line. Whoops, sorry about that. This is the same line, just in a different form. Okay, next problem. Remember what I said you need? Point and a slope. Well, in the next problem, we're missing a slope. We're given 2 points, but no slope. Okay, but we certainly do know how to calculate the slope. So I'm going to first calculate the slope here. I'm going to do y2, so that's a 2, minus y1, which is a 3, over x2, negative 1, minus 1. So that is negative 1 over negative 2. That's 1/2. Okay? The 2 negatives make a positive. Now all I need to do is take a point, either point, doesn't matter, the point and the slope, and put it into point slope form. So I'm going to do y minus the y coordinate equals my slope x minus the x coordinate. And again, you can leave that in that form, or if you would like, you could transform it to slope-intercept form. If you use the other point instead, had we have used this point, it would look different in point-slope form, but when you transformed it to slope-intercept form, it would be exactly the same. Okay, the next two are pretty quick. Write the equation of a vertical line. If you remember, the vertical line, the equation of a vertical line is always x equals something. Okay, so in our case, I'm going to put x equals, well, remember, x stays constant and y can be whatever it wants. So what's my x? It's 4. So the equation of this line is x equals 4. X stays constant, y can be whatever it wants. So same thing here. I don't know where this red line came from. I want to write the equation of a horizontal line through the point 4, 5. Okay, if I want to write the equation of a horizontal line, I know that a horizontal line, the y remains constant. So the y must always be 5. The x can change, but the y stays constant. Okay, we'll now move on to our last topic, which is parallel and perpendicular lines. Again, I'm moving through this fairly quickly. This should be a review for everybody. Parallel lines have the same slope. If one were steeper than the other, they would cross. So if I want to write an equation, remember I'm probably going to use that point-slope form, I need a point and a slope. I want to write the equation of a line that's parallel to this line. Well, if it's going to be parallel to this line, it's going to have the same slope. So I'm going to use a slope of 2 for my line. I'm going to use m equals 2 because I know my line has to be parallel to that line. Now I'm not going to use the same y-intercept. The y-intercept has nothing to do with my new line. But my line needs to pass through this point. So I have the point 8, -1. So I have a point and a slope. I put it in point-slope form. I do y minus -1, be careful of those negatives, equals my slope, x minus x1. And again, if you're not told to put it in slope-intercept form, you can leave it here. The only thing you can't leave is your double negative. So make sure you change your minus to a plus. Okay, in the next equation, the only difference here is that this equation is not in slope-intercept form. So it's a little difficult to recognize the slope. So before I can write the equation of the line that's parallel to this one, I need to know the slope of this line. So I have to do a little bit of work. I have to take this equation and I have to put it into slope-intercept form before I can identify the slope. Okay, so the first thing I'm going to do is subtract the 2x from both sides. So I would have -y equals -2x minus 2. I'm not quite in slope-intercept form yet. I've got to get rid of this negative. So I divide everything by -1 or multiply it by -1. So I get y equals 2x plus 2. Once it's in slope-intercept form, I can easily recognize now that the slope is 2. It happens to be the same in this form, the number in front of the x, but that is not always the case. So make sure you put it into slope-intercept form first. Okay, so now I have my slope at 2 and my point of -1, -3. So I'm ready to put it into slope-intercept form. I'm sorry, not slope-intercept form, point-slope form. So I'm going to do y minus -3, y minus the y-coordinate equals my slope, x minus the x-coordinate, x minus -1. Again, it's perfectly fine to leave it in point-slope form, unless you're told otherwise, but do not leave your double negatives. So make sure you change your minuses to pluses. And then you're good to go. Okay, lastly, we're going to talk about perpendicular lines. Perpendicular lines do not have the same slope. Okay, a couple of things I want you to notice. I'm going to draw some perpendicular lines here. In order for two lines to be perpendicular, one has to have a positive slope and one has to have a negative slope. That doesn't mean that the slopes are just opposites. They are what we call opposite reciprocals. In other words, their products equal -1. So if I wanted to write the equation of a line perpendicular to this line, I am not going to use the slope of 2. If I use the slope of 2, my line would be parallel to this line. I need to use the slope that's the opposite reciprocal. So instead of using 2, that's a positive 2, I'm going to use a negative, and then I'm going to flip 2 over to be 1/2. And then I'm going to use the point 8, -1. So my equation would be y minus -1 equals -1/2 x minus 8. Okay, and then I'm just going to change my minus to be a plus, and there you have the equation. Okay, so the next one works the same way. We figured out previously, this is the same equation that we used in the previous problem, that this slope is 2. So again, I'm not going to use 2 for my slope. If I use 2 for my slope, my line would be parallel, so I'm going to use -1/2, the opposite reciprocal. And I'm going to use this point, -1, -3, so I can simply jump to, I'm going to jump some steps here, y plus 3 equals -1/2 x plus 1. Okay, there you have it. So I gave you some extra practice problems out of the textbook right here if you'd like to do them. Mostly this review should help you with your algebra review packet. Thanks for watching.